I am Anil Kumar. Welcome to my series on graph. In this example, we'll also look into rate of change and see how that helps to sketch fairly accurate graph. We'll use the techniques of differentiation. The question here is, consider the function f of x equals to x cubed minus 4x squared plus x plus 6 within the interval minus 2 to 4. Find turning points and classify them as local, maximum, and minimum of f of x. B is draw the graph of f of x, and C is k is an integer for which the equation f of x equals to k has exactly 3 solutions. Use the graph to find all possible values of k. Now let us see how to solve this question. First part is to find the turning points. We are given a cubic function. As most of you know, for a cubic function, positive leading coefficient, the graph will look like more or less like this. If it has 2 turning points, right? So this is always a continuous graph. Positive leading coefficient means right side is up. And if the power is 3, the degree of this polynomial is 3. In that case, we could have at the most 2 turning points, which I have taken here, right? So maximum, we could find 2 turning points. There could be 1 or there could be none also, okay? Now part A is to find these turning points. Now how do we figure out where are the turning points? As you can see from here, if I'm trying to draw a tangent line to the curve, then at the turning point I have horizontal tangents. So that is key. So the key here is we have horizontal tangent lines at turning points. So that is first thing. Now second thing is that you need to classify them as local, maximum, and minimum. So how do we do that part? To figure out whether it's a local maximum or a minimum, we actually look for the tangent line slope on the left and right side. So on the left side, if it is a maximum, you see the slope is positive, and on the right side of the turning point, the slope is negative. So the second point here is that if the slope changes, or you can say slope is rate of change or the derivative, if the slope of tangent changes from, now there could be 2 conditions. It could be from positive to negative, right? In that case, we have maximum. And if it is from negative to positive, then we have minimum. As you can see here, on this turning point, just before the turning point, the slope is negative, and after the turning point, the slope is positive. So when the slope at a point very close to left side is negative and the right side is positive of a turning point, in that case we have a minimum at the turning point, right? Otherwise not, right? So these are the conditions when you have maximum or minimum. So this kind of analysis we do using analysis of the first derivative. So when we have to find the slope, first derivative is used. So first derivative provides slope of tangent line. So coming back to the question, to find the turning points, we need to first find the first derivative. And for turning points to be located, this first derivative should be 0. So horizontal tangent line means we'll say that the first derivative, which we write f dash x, should be equal to 0. When we say changes from positive to negative in this area, first derivative is greater than 0, then it is positive. In this area, the first derivative should be less than 0, then it is negative. Do you see that? So when we say that the slope changes from positive to negative, we are analyzing the first derivative. It is positive on the left side, 0 at the turning point, and negative thereafter, very close to it. Then we have a maximum, right? And what we have here is local maximum. And if it is changing from negative to positive, we have local minimum. Now that is one way of doing it, so let's call this as one way of doing it, right? Now here is another way of doing it. So the second method to find the slope is to analyze for concavity, right? That is using second derivative. So you see this part of the curve is concave down. So this part is concave down, that is concave up, right? So here we have concave up. And if it is concave up, we have local minimum. And here we have concave down. Opening downwards, you can say. Opening upwards, you can say, right? So concavity is decided using second derivative, right? So the second derivative, which is also written as f double dash x, if it is greater than 0, then the graph is concave up. Let me write plus here, right? Then it is concave up. And if the second derivative is less than 0, then it is concave down. In this portion. Do you understand? Negative, let me write. So you could check for second derivative. Value at this point for second derivative, if it is negative, it is going to be local maximum, and if positive, it's going to be local minimum. So either one of these tests can be used to verify local maximum or minimum. Is that correct? So we are going to use this strategy to find the turning points and then to classify them as local maximum or a minimum. So with this in mind, let us really answer the question now. So we're given the function f of x as equal to x cubed minus 4x squared plus x plus 6. That is the interval. We'll look into this also. Okay, let me write down. So the first derivative, we are going to use the power rule. So some of you may not know about it, so I'm just writing here. If we have a function a times, a is a constant, x to the power of n, then the first derivative will be, constant remains as such, n x to the power of n minus 1. That is the power rule for polynomials. This is what we use. So that is the base. So now here we'll apply the power rule and write down the derivative. So n is 3, so 3x squared is the derivative. Here 4 times 2 is 8, so we get minus 8x. Here the power is 1, so it will be 1. For a constant, it is x to the power of 0, so the derivative is 0. So we get our first derivative. Now to find turning points, we'll equate this to 0, right? So let me write down. Turning points means f dash x should be equal to 0. That means that 3x squared minus 8x plus 1 should be 0. Now 3x squared minus 8x plus 1 can only be 0 at the turning point. So let's see how to figure this out. But before that, let me also find the second derivative, since we might just need it, right? So let me write down what second derivative is. Second derivative is derivative of the first derivative. So 3 times 2 is 6, we get 6x. And the derivative here is minus 8. So that is the second derivative. Let me give equation numbers to these since we are going to analyze them. Okay, so we have them. Now, we'll consider turning points. Okay. As I was saying, the first derivative should be equal to 0. So that means we have 3x squared minus 8x plus 1 equals to 0. Now we should use the quadratic formula to figure out the zeros. Quadratic formula is basically minus b. So if you write a general equation, ax squared plus bx plus c, then it is minus b plus minus b squared minus 4ac over 2a. So using that formula, we get the value of x as equal to minus of b is 8 plus minus square root of b squared. So minus 8 squared is 64 minus 4ac. 4 times 3 is 12. Okay. Over 2 times a means 6, right? 2 times 3. Is that clear to you? Now let's use calculator to figure out these values. So within square root, I have 64 minus 12, which is equal to 2 square root 13. Let's take a decimal value, 7.21. So we get this as 8 plus minus 7.21 divided by 6. So what I'll do here is we'll just calculate two values on the right side, right? And then we'll analyze them. So one value, let's say x1, is 8 plus 7.21 over 6 approximately. The second one here is 8 minus 7.21 over 6. Okay. So we have 8 plus 7.21 and then we have divided by 6. That gives us in decimals equal to 2.535. The other one, 8 minus 7.21 divided by 6 is equal to, in decimals, 0.13. Let me write like this. Okay. So these are the two turning points since we have zeros at this point. Correct? Now, so these are the x values. You can always find the y values. Let's find the y values also at these turning points. So the y values will be, let's substitute in the given equation. So we have, let me write 2.535 whole cube minus 4 times 2.535 square plus 2.535 and then we have plus 6. The y value is minus 0.879. Okay, so let me write here the coordinate points. So f at x1 is minus 0.8, let me write 88, and f at x2 is, we'll change to 0.132, right? And then figure out the answer. Okay, so I'll just change the root here to 0.132, 0.132 0.132 0.132. Okay. The answer is 6.064. Let's say 5, right? So we're just rounding it. Okay. So we got two turning points here. So at least we have the turning points. So first part is identifying the turning points. Turning points are rounding them to two decimal places. We have on the left side x value smaller 0.13 and the value is 6.0, let's say 7, okay. And the second turning point is at x equals to 2.54, and the value is minus 0.88. Okay, so these are the two turning points for the graph. Now we need to figure out whether these turning points are maximum or local minimum, right? So as we discussed, we'll analyze the second derivative. So we also say second derivative test. We already have the second derivative function here, which is 6x minus 8. So in this, we'll substitute the x value. So the left side is 0.132. Let me write down this value first. Okay, so when I substitute, I get 6 times 0.132 minus 8. So this is much smaller, so we definitely get this value as less than 0. So that is sufficient. So when I get second derivative as less than 0, then the nature of the graph is like what? Nature of the graph is it has to open downwards. And that means what? So it is negative. So that means we have a local maximum. Do you see that? Now, let's find the second derivative for the second point, which is at 2.535. So we get 6 times 2.535 will be around 15, right? 535 minus 8 will definitely be greater than 0. So in this case, the graph is going to open upwards and we have local minimum. Is that clear to you? So that is how we have figured out that our turning points are local minimum and maximum, right? So that is how we'll classify them. So our answer here is that we have local minimum, and the point local minimum is on the right side, which is 2.5, let's say 4, x value. The y value which we calculated was minus 0.88. And we have a local L maximum at on the right side, which is at x equals to on the left side, which is x equals to 0.132, and the y value calculated was 6.07. Is that clear to you? So that is how we found local maximum and minimum. So approximately this particular graph will be as expected like this. Is that clear to you? So we have local maximum first at x equals to 0.132, and then we have local minimum at 2.5. Is that clear? Now, in the second half, we'll see how to graph this function. We already have two critical points, local minimum and local maximum. So we have already found local maximum and minimum points. Let me write down those points. We have local minimum at a point which is 2.54, and the value is minus 0.88, and we have local maximum which is at a point which is 0.132, let me write 0.13, and the value was 6.07. Correct? Now, we'll find the other points to sketch the graph of the function x cubed minus 4x squared plus x plus 6 within the interval minus 2 to 4. So let's get our points. So we'll do the calculation with few points. So we can take points as mentioned here, minus 2, minus 1, 0, 1, 2, 3, and 4. We'll calculate, the formula is x cube, so we'll calculate the cube, minus 4x squared minus 4x squared plus x plus 6, right? And then we are going to add them all. So some of you can use the calculator straight away to find the value. So minus 2 cube is minus 8. Let's do the cube first. So we get minus 1, 0, 1, 8, 27, 64, right? So that's a minus 4x squared. So square will always be a positive quantity, right? And then negative 4 will make it negative. So all these will be negative, right? So square is 4, 4 times 4 is 16, 1 times 4 minus 4, 0, 1, so it's minus 4. 2 square is 4, 4 times 4 is 16, but all will be negative, right? 3 times 3 square is 9, 36. And we have 4 square, which is 16 times 4 is 64. So it becomes 64 minus. Good. X values. We'll write these values, which is minus 2, minus 1, 0, 1, 2, 3, and 4. Add 6. So do all this to get your points, correct? So all these negative values, and this, so minus 10, and that is minus 20. Right? So 6 and 6, 10. Okay. Now in this case, we got minus 6 and 6, that's a 0. Here we get 6. Here we get again 0. In this case, 8 and 2 is 10. And when you take away this, you get what? 10 minus. So that is also a 0. Okay. That's also a 0. And here we have minus 27. Okay. 27 and 3 is 30, 36. So this is another 0. That is 0, and we get a value of 10. So we got something wrong. There can be only 3 zeros. Okay. So let's calculate. This is minus 6. That's correct. Now here we have, okay, this is wrong. So we have here 6, 7, 8 minus 4, which is 4. Okay, that makes sense. So we have zeros at 2, 3, and 1. And the value we are looking at is minus 20, one extreme, and 10 the other one. Okay. So I think we could sketch most of the points. That may be difficult for us, minus 20. So we are going from minus 2 to 4 in this graph. What we will do here is that, and we have a 10 value here. So looking at this, we'll choose a scale of 2. So 2, 4, 6, 8, 10. Okay. So somewhere here, if I draw my x-axis, right? And then we are going to minus, so 1, 2. So let's say this is our y-axis. Now let's plot our points. We are using this scale as 2, right? And this scale as 1. So the first point, we can get into this later. So we'll kind of, minus 20 will be at minus 2. 2, 4, 6, 8, 10, 2, 4, 6, it goes further down. So we'll say it is like going very down, right? So we'll ignore this point, but we'll do the others and approximate our graph. Is that clear to you? So at minus 1, we have 0. So that is 1. At 0, we have 6. 2, 4, 6. So 2, 4, 6. And then we have 4 at 1. So 4 at 1. And at 2, we have a 0. At 3, again, we have a 0. And then at 4, we have 10. So at 4, we have 2, 4, 6, 8, 10. So that is the graph. Minimum value which we found was at in between 2 and 3. So 2.54 minus, so less than 1. So it's kind of here, very close. Is that okay? So that's the local minimum which we have taken from earlier exercise, the turning point, right? The other turning point is at maximum, 0.13. So slightly after the y-intercept, you get the idea. So the graph will look like something like this, right? We'll just go like this with an arrow, right? On this side, that becomes our turning point, and this goes kind of like this, and there you go. So that becomes the graph of our function f of x. Is that clear to you? Where the coordinates of this point are, that is our local maximum, is 0.13, 6.07, and the coordinate of local minimum is at 2.54. We have minus 0.88. Is that clear to you? Okay. So that is our graph. Now, let's look into part C, which says k is an integer for which equation f of x equals to k has exactly 3 solutions. Now, f of x equals to k means what? So when we write f of x equals to k, it is a horizontal line. And we are looking for 3 solutions. That means the horizontal line should go through the values in between maximum and minimum, right? So that is where you could get a horizontal line, for example, like this, with 3 solutions. Do you see that? So the point of intersections are these solutions. Now we need to use the graph to find the possible values of k. So k is integer. So k is integer. So it has to be, since this value is 6, so the value 6 will work, right? So we have, so 1, that will give us 3 solutions. This will give us 3. All these integer values. Do you see that? And also 1, 2, 3, 4, right? So those are the values. So we get our values which are between, the minimum is 0.88, so minus 1 is outside, right? Do you see that? So the integer values will be 0, 1, 2, 3, 4, 5, and 6. So these 6 values could be the value of k to give us 3 solutions. Does it make sense to you? Very interesting form. So that is how we could use our graphing techniques to get solution to questions. So this is a very beautiful question where we have taken up the concept of derivatives to figure out position of local maximum and minimum, and then we have analyzed and used our graph to find solution of a question. I hope that helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that will help. Thanks for your time and all the best.